Mr. Chairman, ladies and gentlemen, dear colleagues, as you see, the title of my paper or presentation, better to say presentation, will be Serbian energy efficiency problems. But I think on the end of this presentation, you will see that this procedure, actually it will be a procedure, how to calculate and how to find out what will be the best for your country or for the region, and how to prepare the action plan to do something, and you will see that you can use for any country. And what is the main assumption for this is to have a reliable database. That's the most important thing. And to select particular energy efficiency indicators, or better to say energy indicators, which are mostly physical indicators without mixing the economical influence, because only what we have on disposal is GDP, for example, on the national level. But GDP fluctuates too much, and it's very difficult to find out the good database for GDP for all countries, because always you have to compare some indicators with your country and some region or some other countries. And let's start with the topics to be considered. The first one is global position of Serbia. That means that we will compare the position of Serbia in the field, of course, of energy efficiency and renewable energy. After that Serbian energy system, it will be only one slide, which I will show you how to say what is the energy mix of Serbia. Energy efficiency indicators, I will mention all so far used energy efficiency indicators. And after that, I will present and evaluate of energy efficiency indicators for particular energy efficiency indicators for the region and Serbia and the countries in the region. And after that, the key for making efficiency energy, effective energy efficiency policy, because on the end, we have to form, actually, to issue the energy efficiency policy. And that's the main, actually, goal when you start to implement any plan in your country. Energy efficiency multi-criteria decision analysis for Serbia, that's general actually methodology, how to put all influencing factor together, and how to analyze, how to ponder them, and to find what you have to do. And on the end, you will see of course, the conclusions. Global position of Serbia, we will analyze having in mind the indicators as follows. Total primary energy supply per population. You will see that's not energy intensity, because I use total energy supply per population, because that's a physical actual indicator, and it will be a ton of oil equivalent per capita. Why I use this one? Because all these figures, total primary energy supply and populations, are well-known figures for each country. And that means that mistake in this is small. Expecting, for example, that there is no problem for calculating this indicator. The second one it will be electricity consumption per population, kilowatt hour per capita. The third one will be CO2 emission per population, ton of CO2 per capita. Actually, that's calculated, always it's calculated, having in mind the total primary energy supply and energy mix. And on the end, we have to use the GDP, that means purchase power parity per population, and we will use the US dollar exchange rate from the year 2005 per capita again. Now here is the first diagram. actually the first indicator, total primary energy supply per population, and the year. As you see that about 20 years are covered with this slide. And what we can see on the one side, we have European Union 27, because now we have European Union 2028 because Croatia joined the European Union, but they didn't correct the database. But I think it will be happen very soon. And on the other side, we have Serbia. And what we can see that very stable total primary energy supply. That's very good for European Union 27. And for Serbia, you see that we have increase of total primary energy supply per population, per capita. And as you see, the scatter for European Union is small, and for Serbia is high. In year 2009, in both countries, group of countries, European Union 27 and Serbia, you will see the drop of total primary energy supply per population. What is the consequence of economical crisis which start actually on the end of 2008. And that means that, for example, this indicator are sensitive for such type of shocks we have in the economical. And it's very important to stress that in this and other slides, in any indicators, it's not possible to analyze the indicator like a spot, like a figure. Let's say it's 3 or 3.1, 3.15. Definitely it's not good, because behind this figure, behind this value, there is a full story about the economy, social problems they have, political problems they have in that countries, what really influence this indicator. We can conclude after this one that in the period from 90 to 2010, TPS per population in Serbia was growing, while in European Union it was in stagnation. TPS per population in Serbia is much lower than in European Union 27. If we say that, for example, population, they use energy as much as they need, for example, for living, for cooking, for whatever, for air conditioning, and it could be comparable in all Europe, where is the difference? The difference is in industry, in economy, and that means the difference is used to produce, to increase the gross domestic product. That's very important. The growth of TPI, total primary energy saving population in Serbia, causes concern, in particular when it is well known that the economic activities are very slow, and that's not good. The second indicator I already mentioned so far is electricity consumption per population, kilowatt hour per capita, and we see that in both group of countries, European Union 27, in Serbia, it increased. Again, we can say that the scatter in European Union is much smaller than in Serbia. That means stability in the economy. And the problem is that in Serbia it goes up, and we have a very, how to say, poor economy, and actually decrease in economical growth, and that's the problem. That means that no measure of energy efficiency increase. In the same period, the growing trend of electricity consumption is approximately the same as in European Union. However, electricity consumption in European Union 27 is much higher than in Serbia. Again, we can explain only by economical activities, which is much higher in European Union 27. Here is one very, very interesting graph. That's CO2 per population, and we see that the decrease in European Union 27, very stable decrease, and increase in Serbia. What is again very, very interesting. And actually, this increase followed the increase the total primary energy supply per population. As I already mentioned, that this one is calculated from total primary energy supply. And that means absence of any action in connection with energy efficiency and in connection with renewable energy. That means that poor energy policy we have, or maybe we have energy policy. A few days ago, the Minister of Energy visited Novi Sad, where I am living and working, and we discussed about this, but the problem is I think that the politicians doesn't care about this. They have much more important about many other things and some new ideas about the new plants and whatever. And actually, the main resources is here. Actually, they have to see what to do with that, with these indicators. The growth of CO2 emission in Serbia is very obvious, while in EU 27 it is falling. Although CO2 emission per capita is lower in Serbia than in European Union 27, the growth of CO2 emission is not the consequence of economic growth, but of further decline of energy efficiency and the failure to utilize renewable energy sources. The pronounced growth of CO2 emission indicates the absence of the utilization of renewable energy sources and the absence of effects of measures aimed at increasing energy efficiency. That's a conclusion after analysis such a diagram. And because of that, I think that you can use for your own country, for example, the same European Union 27, and if you put your own country, you will see where you are. And if you use the same, how to say, the procedure for analysis, I think that you will get soon the really good answers or what have to be done. Here is GDP, PPP per population, and as you see that we have a very stable increase of GDP per population in European Union 27, and slow increase in Serbia, but it is much lower. And the consequence is because we use too much energy per capita, but we didn't use this energy to increase production, to improve the economy. We used to improve our own living standard, unfortunately. Everything becomes clear when GDP per capita is compared. This indicator refers to economic activities which are at very low level in Serbia compared to European Union 27. This means that increased consumption of total primary energy supply emissions can be, and electricity and consequently growth of CO2 emissions can be the result of unfavorable overflow of energy consumption from productive to non-productive activities, public and residential sectors. With all this, there is a decline in the number of population. I think we have the highest decrease in population in Serbia, in all European countries. Basic social and economic characteristics, because as I already mentioned, behind each of this pot, of this value, you have to see what is or you have to prepare the analysis about the economical and social characteristics of the region and the countries. Is okay? Okay. No damage. If you compare Serbia, and what we can say for Serbia, what I already say, that slight decline of population, and European Union we have 27, we have a very slight growth of population. We have slowdown of economical growth in Serbia, stable economical development in European Union, considerable growth in primary energy consumption per capita, stagnation on the other side Growth in electrical energy we have in both region. Considerable growth in carbon dioxide emission per capita, considerable fall in carbon dioxide emission per capita. And what is very, very important to stress, that GDP in Serbia is only 9,600 US dollar, and in European Union is much, much higher, more than three times higher. And that's economical activities. As I already mentioned, only one slide because of time. I think just to give you impression what kind of energy system we have in Serbia. As you see that coal is let's say about 8 million ton of oil equivalent, and it is 55.5% of total primary energy supply. That means we use coal. Unfortunately, it's a lignite, very poor, and very poor quality of coal, but we use them to produce electrical energy. And if you see on the bottom, electricity, that we have let's say, a very small import of electricity, and I think that this year we will export electricity a little bit, not too much. That means that that's our system, 55% coal. Crude oil, 21, let's say, percent. Oil products, 6.6%. Gas, 9.7%. Nuclear, 0. But the problem is geothermal, solar, combustible, renewable, and wastes. Very poor, very low. And if you say that, for example, the combustible and renewable, I think that it's about 2%, but 2% is firewood that we traditionally use in the rural area. But actually, energy mix is not good for Serbia. And, but it is important to conclude from this slide that there is no renewable energy. And the last calculation for what we have to reach until 2020 in Serbia is that we have to use 27% of renewable comparing the total primary energy saving. We are very far from this. And the politicians, they will use it 2019. They will say that we will reach it, but there is no chance because they have to think much, much earlier about how to reach this 27. But I don't know really who calculated. That's European Union calculated. That means that they have some formula, and they put in some computer and calculate that we have to increase up to 27 because we have potential. In Bosnia, it is 40%. Unbelievable, but somebody play with this without looking at the real situation they have in the particular country. Energy efficiency indicator concerns everything related to the prevention of the energy losses within the system. It is reduced to the very simple and understandable equation. Energy useful equal primary energy minus losses. Losses occur in energy transformation, transmission, distribution, and uses. And the first three categories mainly depends on available technology. And decrease of losses within the users needs to be resolved by both technical and non-technical measures. And I think that the main problem is in the last one, end users, because there is a lot of entities influence the energy efficiency, and the problem is how to organize them and how to prepare something what will be acceptable for all of them. Well, in my opinion, the energy efficiency should be understood as a set of organized activities which are implemented within the boundaries of the defined energy system with the aim of reducing the consumption of input energy, harmful gases emission, and energy cost, with no change to the level of services performed or with the creation of a new value in production process within the defined system. The definition itself indicates the complexity of the problem arising from the need to connect people, procedures, and technologies in order to achieve consistent and permanent improvements in energy efficiency. The main problem are people, because as you know that they have to change. You can change technology, you can change and prescribe procedure, but to change the people is the most difficult. And if you have a lot of them in this chain, you have a problem, and we know this. To improve the energy efficiency, it is necessary to reduce excessive and unnecessary use of energy by introducing legislation and energy policy which encourage changes of behavior. The main problem, how to change behavior. Reduce energy losses by implementing energy efficiency improvement measures and by introducing new technologies. Monitor energy consumption in order to get the full picture of energy consumption and consequences thereof. Manage energy consumption by improving operational and maintenance practice. Well, it looks very simple, but to put in force, it's too complicated. Today, energy efficiency is unfortunately a matter of technology and not the knowledge. I think that we have not only this energy efficiency and renewable and energy, in our society we have a problem of knowledge. Because I think that we believe too much in the technologies, and the new technology is often uncritically and very aggressively imposed on users without substantial evidence of their efficiency in relations to the technology used here there. That's the problem, I think, in my opinion, that's a great problem, because very aggressively we are pushed to change and to replace, for example, the lighting, without waiting old technology to shut off, and why we have to replace immediately. And I think that we have to put more critical, let's say, view, and to analyze why we have to change, and because I think that, how to say, the culture of money is on the top. And everybody, they push us to do something when it is not necessary. And it is really not necessary always to change and to use some new equipment, for example. Actually, only unconvinced marketing style explanations are offered. That means unconvincing marketing style, which do not provide enough knowledge to users intending to apply new technologies. And in my opinion, I think that we are the audience which have to be very careful, and we have to promote the knowledge, not marketing. Because of its complexity, there are no doubts that energy efficiency is difficult to measure, and actually it's not possible to measure directly. There are 6 groups of indicators which are mostly frequently used and also employed in various situations. I will just quickly pass through all of them. Energy intensity, I think that it's very well known, is a relation between energy consumption measured in energy units and activity indicators measured by monetary units. The most popular is GDP, divide the total primary energy saving per GDP. The next one is specific consumption. It's very popular too. Connects energy consumption with activity indicators, which is measured by physical units, tons of steel, number of vehicles, and etc. And we use this specific one. That means we use per capita, per population. That's a physical indicator, and I think it works top up and bottom. In all situations, you can use specific consumption. Energy Efficiency Index provides overall assessment of trends in the energy efficiency sector. It is calculated by means of weighted average of subsector indicators toward end users, manner of transportation, etc. That means that you have to establish indicator, something will be 100% or 1, and you can easily compare if you go up and down what is the situation. This one is very interesting, but not on the national level, but on the lower level. That's a diffusion indicator, have been introduced in order to supplement existing energy efficiency indicator because they can easily be tracked. Their aim is to improve interpretation of trends which have been noticed relevant to energy efficiency indicators. There are three types of these indicators: market penetration of renewable energy sources. For example, number of sold biomass boilers in the country, percentage of fuel wood boilers for heating, etc. That means that you have to have a very reliable database, statistical from the country, where you will find the number of sold biomass boiler. And I think that this one is really good indicator, and you will see the effect of your energy policy you introduce. And let's go to the next one. Adjusted energy efficiency indicator. When you like to compare, for example, the different areas in Europe, for example, you have to take calculation weather conditions, degree of load, operating hours, and similar. That means that you have to adjust something and to put them on the same level of temperatures, outside temperatures, or number of operation hours, and so on. Target indicator aimed at providing reference values which will show possible improvements of desired energy efficiency or possibilities for energy efficiency in a certain country. I think that, for example, if you compare different countries, and if you compare the economy, social situation, political situation, you will put your own target comparing those countries, having in mind in which way your changes are going in social, in economic, and political. And the energy efficiency indicator pyramid is like that, and of course we discuss and we deal only with on the top level, on the national level today, but it is possible to go to the bottom, to the process efficiency, and of course you have to adjust your indicators for each particular problem you have in your own country. And now, just quickly, the energy efficiency indicators. As you see that I put Serbia, Croatia, Bosnia and Herzegovina, Albania, Macedonia, Montenegro, Hungary, Romania, Bulgaria. That means that the countries in the region, and I compare with OECD countries and the world, of course. But we have no time to go carefully to this. But as you see that if you compare the land area, that means that this in the bracket, this on the first column in the bracket means where we are from the biggest country, the Russia, is the having in mind land area. And as you see that we are in the second part of, all those countries are in the second part of the list. This is compound indicators for all those countries, and as you see that, for example, the density of population per square kilometer is almost the same in all these countries around, but it is higher than in the world, and it is, what is interesting, higher than in OECD countries. Here is the group of indicators which show us similar, like the first one. That's total primary energy saving per capita, but we compare with OECD countries. As you see that they have decreased, a slow decrease in total primary energy saving. That means we have to add OECD countries, means all European Union countries, plus Canada, USA, Chile, Japan, and some other countries. That's OECD countries. Actually, they are developed countries. And if we compare on the bottom, we have all neighboring countries, all countries from the region: Serbia, Croatia, Bosnia and Herzegovina, Macedonia, Bulgaria, Romania, Hungary, Albania. And as you see that in all those countries we have increase. That's the developing countries. All those countries are developing countries. And we have increase of total primary energy saving. That's vice versa than it has to be. Electricity consumption in OECD countries are stable. And as you remember, in the European Union, it goes down. How it is possible? And total primary energy supply goes down in OECD countries. Well, that's, again, we have to explain what's happened. But it's happened that they changed the economy. As you know that many industry from the United States moved to developing countries, energy-intensive industries moved. And that's the reason why they decrease, not only one, but that's one of the reasons they decrease, and electricity is stable. CO2 goes down in OECD countries, in all those countries goes up. And GDP is like that. But I will finish with this energy intensity versus GDP. As you see, that's a different, how to say, arrange the data. And just to explain this very strange, Iceland, for example, high GDP per capita, comparing the Serbia, very low GDP, not very low, but low GDP per capita, and but extremely high total primary energy saving per GDP in Iceland. How to explain this? And if you look the next one, CO2 per GDP, Iceland, very low. Comparing the Serbia, it goes up. Very strange. Denmark is somewhere here on this diagram, and if you see the Luxembourg is extremely high GDP per capita, but Luxembourg is a small country, no industry. They have only banks, and they have great salaries, and because of that they have increased, but very low CO2 per population, no industry, and they just make money. What is, if we compare Iceland and Serbia? Enormous primary energy consumption comes from the consumption of electricity in the aluminum industry. 74% of total electricity consumption is spent in the aluminum industry. And because of that, they have so high consumption. Since this consumption is connected with industry, it is obvious that GDP in Iceland is high in comparison to Serbia, because all this excess of electrical energy they spend in production to increase the GDP. Comparing to Serbia, we have high, but we use for our own, for increase the living standard of living, not in industry and not in, to increase the GDP. Since the consumption, at the same time, the emission of CO2 in Iceland is much lower than in Serbia. Again, very strange. As you know, where is Iceland? You know that that means that they have to produce this electricity. The reason is the fact that in Iceland, hydro and geothermal potential are used for the production of 95% of electricity. And in Serbia, the majority of electricity is produced using coal. And as you see, that I think that this is a very good example. This is extreme, and you have to be very careful if you like to compare the figures, values. It's not possible. Behind this value, you have to explain and put explanation about the economical, social, and political situation in the country. I think that that's. I have a, let's say, some other slides, but I think that I will finish here. just to mention that on the end we use multi-criteria analysis and put all those factors in this analysis. And on the end, we finished with the list. Just show you the list. That's the following criteria we use. And we have results of analysis. We have a building construction, what we suggest. Industry, what we suggest. Electricity power plants, thermal power plants, transport, energy policy legislation, sustainable energy development. As you see, this shaded area means what we, after analysis, what we suggest to our politician, decision maker, what they have to improve. And on the end, we have the list of, actually that's action plan, what we suggest to our policymaker, how to improve the situation and how to improve, how to put in force actually the energy policy. Unfortunately, everything is, I think, very clear, and if you check it and you can use for your own country, on the end you will get the list what has to be done in many areas on the horizontal level, in many ministries, what they have to do. But without political will, there is no chance, like in any other countries. Somebody on the top, politicians, has to decide to put in implementation what we prepare and the action plan, actually established action plan. Well, that's it. Thank you.
Professor Gvozdenac, for your very realistic picture of the situation in Serbia. We are now in position only for 2 short questions according to the schedule. Are there any questions for?
Yeah.
Please.
Thank you, Professor Gvozdenac, for a very interesting presentation. My name is Dusan Gvozdenac. I'm coming from the University of Dubrovnik. I agree with you that about those indicators you selected, which I not agree in details and the numbers, that the main reason of problems in Serbia are that we still have the same power plants and we consume more energy in households and in industry. And I think this is why, because our country is subsidizing consumption instead of helping some energy efficiency policy. My question is, what do you think about the Serbian National Energy Efficiency Action Plan? And if there are some reasons for the energy consumption in the future in Serbia, which are estimated in new energy strategy of Serbia, the Serbian National Energy Efficiency and National Renewable Energy Action Plan, and what are policies you recommend for household sector in Serbia?
Thank you. Serbian Energy Action Plan, Energy Efficiency Action Plan. I think that the first Energy Efficiency Action Plan was issued, I think, 3 years ago. And now, this year, on the end of this year, we will start to make another Serbian Energy Efficiency Action Plan number 2. It will be financed by EBRD. But the question is, what's happened with the first one? Nothing. And that's what I already mentioned. What you mentioned, definitely, I agree with you, because you know very well, but in the second part of this presentation, I put this, what has to be done and how to prepare. In this list means what we have to put in the energy efficiency action plan. But as I already mentioned, the previous action plan, number 1, was, let's say, good. But we didn't put in force. That's the problem. Somebody decided to prepare the documents, and after that, doing nothing. No action. Action plan without action means zero. Okay.
Professor Rašković.
Thank you. Okay. One question which you didn't mention, but I think it's very important. This is the price of electricity or the price of energy. Because there is a balance somewhere there. Balance, the transition to renewable energy sources, somebody has to pay, as you say in the paper. On the other side, the investor, because Serbia is trying to reindustrialize this country, try to make a new industry, always try to find the countries with cheap electricity, cheap price of electricity and cheap price of energy. About that balance. Thank you.
As you know that we are obliged to increase our prices of electricity, and it's happened actually on the high voltage level. On the medium voltage level, it will happen in January next year. They will increase and adjust the electricity because we have to open the market. And it will happen slowly. But what to say about electricity, but I put in this list of the actions what we have to do. That means adjusting the electrical energy prices. Because as you mentioned, and you know that really our prices are very low, and we know why. And but gradually we have to change it. And what we suggest here is gradually to change from year to year. And because of that, I think that in 2014, in January, we will, the medium level of voltage, we will increase the efficiency and open the market. For high voltage level, only one company bought electricity from the outside, not from the EPS, from national grid. And of course, that's Messer Griesheim for Germany. They bought from Germany, but the market is open. That means that that's a first good step to join the European Union. Okay.
And last question.
Thank you very much for that interesting presentation. The thing that I didn't hear at the end and suggestion of the measures, you teach me that the connecting with the people with the responsibility is a key for the success of any program, especially energy efficiency program. Is it was that the plan? Was that in the first action plan, or is it going to be in the second action plan? So how are you going to put the pressure on the government to actually stand up behind the policy, or the next policy of Serbia, energy efficiency will be there on the critical line first time?
Unfortunately, I have not enough time, you know, to list all this, what we found out after the full analysis. We analyzed the indicators and especially the situation. Just to mention that my idea was, when I came here in Croatia, to put the Croatian energy efficiency problems. And I already collect the data, and I have data for Croatia, to compare Croatia with the European Union and OECD countries and so. But the problem is, because in the multi-criteria analysis, you have to put expert opinion. And it's very difficult for me, you know, to be sure how to ponder all these factors, influencing factors. And because of that, I switched to Serbia, just to show procedure. What about the action plan? The first action plan, they already have many of these. But as I mentioned, that the problem is with the people, and in this case, the political will doesn't exist in Serbia to put in force such, for example, a proposal or similar proposal or official action plans we already have. Official energy policy, we have it. We have a strategy. But somebody has to put in force this. That's the problem. Okay?
Thank you. That means the decisions are out of our power.
Yeah, but we have to do this. We have to prepare, and we have officially to put, and we will do this, and we already done. We send to official policy, and that's our duty, like a scientist, like experts, whatever you like.
Okay. Thank you, Professor Gvozdenac. Thank you all for coming on this session. And I will ask Professor Guzovic to present poster session. Thank you.
Okay.